All right. So last time around, we talked about sort of an introduction to the idea of modulus of z1 minus z2. And we said if we have two complex numbers subtracted and there's a modulus connecting them, what we are essentially talking about is the distance between the 2 points. The 2 points, or in this case, 2 points on the Argand diagrams, of course, or here specifically, two complex numbers. And we extended the idea to this particular example where we said uh, modulus of z minus twice I is equals to 3 units. And we said that this essentially, and since z was not known to us, what we could essentially do with our Argand diagram, this being the imaginary axis and this the real axis, what we could do is make guesses of possible positions that z could take. And we said, since twice I is known to us, let's say this is twice I and so on the imaginary axis, we came up with all the points that are essentially 3 units from twice I, and that gave us a circle. Excuse the very irregular circle. But this essentially meant that we would get a circle where the center is this particular complex number twice I. And remember, the minus was just part of the format. It does not represent minus twice I. And that the radius of the circle is 3 units. And all these points on the circumference are possible positions of z. That is what we talked about last time. And it all makes sense because z has to be 3 units away from twice I because of the modulus between z minus twice I. I mean, I hope you have been able to connect these two concepts. Again, let's look into more examples. And one good example to start off is what we already talked about, and that is modulus of z is, let's say, examples. Again, we're talking about lots of examples in this video. Um, and we did this before in order to understand what the modulus of a complex number essentially, when just one complex number essentially represented in our Argand diagrams. And we said if someone said modulus of z was equals to 2 units, this would essentially mean that z is such a complex number which is exactly 2 units from the origin. So z could be here if this was 2 units. Z could be here if this was 2 units. Z could be here if this was 2 units, 2 units, and in any possible direction. And by now, you should be getting the idea that if this is the starting point, the origin, Z could be anywhere on the circumference as long as the radius is 2 and the center is the origin. And that is what we talked about last time, that when I simply say that the modulus of just a particular complex number, I am representing the distance of that complex number, let's say here, it could be here or here or here, from the origin. Emphasis on the origin. Now, how does all of this relate to z1 minus z2? Well, we could have written this as z minus 0 is equals to 2. This could be my z1 according to the format that we talked about, minus, again, the minus being part of the format. This could be my other complex number. তার মানে কি? This statement, which is basically this statement, says z is such a complex number that its distance from the origin, 0 is origin obviously, is 2. And all of this comes together and does give you a circle. And hopefully that clarifies it, because here's the other complex number 0, here's the missing complex number z, and as long as the distance between our missing complex number and our known complex number 0 is 2 units, our z is consistent with this particular question or this particular expression. And we said z could be anywhere on the circle. And just like this particular example, it does make sense, doesn't it? That the distance of this point or this point or this point or any of the points on our circumference and the origin is 2 units. And hopefully that makes sense to you. Again, if you're still confused, hopefully by the end of this video, you'll get an idea of what we're talking about. and you'll see a trend, and a sort of a general trend. Um, so in this case, let's talk about another example. And in this example, let's say modulus of w minus, and I'm going to put a bracket here, 1 plus 2i is equals to 2 units. And I ask you to make a guess, or to draw the possible positions of w um, in my in our argand diagram, this being the imaginary axis and the real axis over here. Now we need to locate w. You need to think about it, and you need to again relate to what we've talked about so far, and come up with um, ways to uh, possible positions of where w could be. Now, for that, you need to first understand this notation. It says that the distance between my missing complex number w, and again, this minus is just part of the format, the distance between my missing complex number w and 1 plus twice I, so 1 plus twice I, that is known to us, right? So 1 plus twice I is something we know. Let's say this is 1 plus 2I, 1 plus twice I, 1 being on the real axis and 2 being on the imaginary axis. So we know this point, and our missing complex number has to be 2 units away from this, or in other words, the distance between my complex number 1 plus 2i and w has to be 2 units. That's basically, that basically says যে আমার complex number w 2 units দূরে থাকতে হবে এটার থেকে. So if you think about it, this being the starting point, 2 units away from this could be in any direction possible, and that should give you a circle. That should give you a circle of 2 units. So this is my center, and the radius is 2 units, because it could be 2 units. My missing complex number could be 2 units in any direction. তাহলে w কোথায় কোথায় হতে পারে? What are the possible locations of w? Anywhere on the circumference. W could be anywhere on the circumference. So by now you should be getting a feeling of how we can use it. Again, if someone gives you an expression like this and asks you to locate possible positions of our missing complex number, this is how you do it. And by now, I think you've gotten a general idea that if I have a missing complex number z, excuse me, missing complex number z, and then a subtraction, and then we have another missing complex number, let's say z1 minus z2, and I say this is some distance d, you should by now get the feeling, Jay, this represents a circle with center z2 and d as the modulus. I hope you've gotten this idea by now. So this is, if you're having trouble, trying to intuitively understand this, maybe this will try to give you a more general idea, sort of a formula, if you will, that you might find handy. Let's look into another example. This time, I'm going to play around with the format a bit. Let's say I have a complex number v, and then I'm going to put a positive 3i, and then I'm going to say the modulus of all this is 1. Now, at first sight, this might seem a bit new to you because we don't have a minus here. But remember, the format for thinking in terms of distance has to involve the z1 minus z2 modulus. So let's do that for here. So in case of questions like these or expressions like these, what you want to do is first modify this particular expression and bring a minus, obviously making sure you don't change the overall expression, just change the format. Now I have a question, an expression that talks in terms of z1 minus, which is part of the format, and z2 being negative 3i. So hopefully this is not too much of a complication for you. Hopefully you've understood that we want a minus in front of the other complex number. So সবসময় make sure you do the work in order to introduce a minus in front of the whole of the second complex number. Now, if I ask you to draw the possible positions of v, it's again very simple. minus 3i is your center, 1 is your radius. Whoops. So I want to correct this. This is radius in terms of circle. Right. Is the radius, and it's going to be a circle around it. So obviously you're going to use your compass, you're going to uh, you know take measurements using your ruler, whatever works for you. Just make sure it's a proper circle you draw using a compass. Now again, I'm going to play around with the format a bit more in this particular example. Let's say I say z uh, minus 1 plus 3i is equals to modulus of 2 plus 2i. Now, this might seem a bit intimidating again, because not only is this confusing, what's with this? Well, the good thing is, this shouldn't, this simply means the modulus of 2 plus 2i. Now, we know, since there is nothing missing here, unlike this, here we couldn't really calculate anything because the complex number here was missing, but this is something we can calculate. The modulus of 2 plus 2i is essentially 2 square, root over 2 square plus 2 square, and that's root 8. So I can modify my question or expression to z minus 1 plus 3i mod root 8. Now root 8 is a number, so I mean now it's more uh, like the other questions we solved. But what about this? Again, this minus is not in front of the whole second complex number. I need to change the form and make sure the minus is part of the whole thing. Now I am maintaining the distance format. Z1 minus being part of the format minus Z2. Z2, the minus being in front of the whole thing. So two adjustments were made in this particular problem. What do you do now? If someone asks you, draw the locus of points that represent Z, or draw the possible positions of Z, all you do is locate 1 minus 3i, 1 minus 3i being here, and root 8 approximately 2 point something, and just draw a circle. But again, I won't go into the specifics here, the measurements and all that. You'll be using a compass, and obviously, uh, you know, graph paper might be given to you, might not be given to you, but that's not a problem. You'll use your ruler when there's no grid, and you'll be able to hopefully get this done. Now, normally these radii aren't really all that complicated, so this was arbitrarily taken. So এটা natural মানে randomly নিচে দেখে হয়তো বা it turned out to be decimal numbers, but usually this is a whole number. So hopefully you've gotten an idea of circles involving complex numbers, circles in Argand diagrams. And before we end the video, there's one little thing that might be applicable for all of these cases, and that is, instead of um, equals to, what would have happened if the equals to got changed to an inequality, let's say less than equals to? Well, it's not very complicated, it's actually very simple. In this case, what they're essentially saying is w is in such a position that it is less than 2 units away from 1 plus 2i. So again, you draw your circle, but again, just treat it like an equals to, draw your circle, except this time, instead of saying that w is on the circumference, say that w is inside the circle. So you shade the entire circle. It could be on the circumference because the equals to is there, but w could also be inside the circle, uh, because the distance from 1 plus 2i could be less than 2. Now the circle's circumference gives you the 2 units boundary, but since w is possibly closer to 1 plus 2i, 1 plus 2i being right over here. W could be somewhere inside the circle. It could be here, it could be here. These are all possible positions of W. All these crosses that I'm making are all possible positions of W, because all these crosses are less than 2 units from 1 plus 2i. So I hope you get the idea. Likewise, uh, in this case, if it was less than equals to, all I would do is draw the circle just fine. But instead of saying V is on the circle, which was the case if it was equals to, less than equals to hole, you would have to shade, just shade lightly inside the circle, because V is inside my one unit boundary, because it's closer to minus 3i, which is my center. And obviously now you've guessed that if it was greater than, I would have to shade outside the circle. Now, how much do you shade? It's completely uh, up to you. Just shade. Just give the examiner the impression that you understand that you have to shade outside. So outside কখন shade করব? When the sign was would sign turns out to be greater than or equals to. এখন another common question is, what is the difference between less than equals to and just less than? Well, just keep in mind, whoops, just keep in mind that less than equals to or greater than equals to, um, these give you solid lines, solid circles, and just less than or greater than with no equals to essentially gives you dotted circles. So next time the question, for example, if the question says modulus of z minus 1 plus 2i is less than equals to 2, for example, draw a solid circle and then shade the inside. But যদি এখানে equals to টা না থাকে, draw a dotted circle and then shade inside. Just so it's just the circle, the boundaries that are either solid or dotted when it comes to equals to in the inequality and no equals to in the inequality. So hopefully you've got an idea of all of this. In this video, we talked extensively about the modulus between two complex numbers, and especially uh, how to come up with possible positions of our missing complex numbers, W, Z, V, when in our Argand diagrams, when this format is given in equals to or inequals to form, or inequality form, and how to make tiny little adjustments, like in this case, so that we can draw our circles. Um, in the upcoming videos, we'll talk about another kind of loci, which is the last thing left. Well, now there are some other examples left as well. But next time around, we'll talking about perpendicular bisectors, and later on we will be talking about how to combine both perpendicular bisectors and circles that we're seeing right now to answer more complex questions. So see you next time.